Now we do the problem under changing the order of integration. By changing the order of integration, evaluate integral 0 to infinity 0 to y e power minus y square by x dx dy. So before going to start the problem, first we have to check the problem whether they are given in the correct order. See here, the lower integration limit as the variable y. Definitely it is for the variable x. So x only 0 to varies from 0 to y. So the order should be dx dy. If it is x means the outer integration limit is for the variable y. So the order what they have given is correct only. What they have given dx dy. Okay. So here what is our aim is we have to change this dx dy to dy dx. So that is our aim. For that first we have to find the region of the integration. So the region of the integration is bounded by the lines. Here, what are the boundaries are? They have given the limit. X varies from 0 to y. That is x equal to 0, x equal to y. So, first one is x equal to 0, x equal to y. And other limit is y equal to 0, y equal to infinity. So, these are the boundary they have given in the question. So, for that, we have to draw the diagram. So, what they have given x equal to 0. X equal to 0 means y-axis. And x equal to y. X equal to y. The next one is x equal to y. It is a straight line passing through the origin. The next one is y equal to 0. Y x-axis. Y equal to infinity means this y-axis is going on to infinity. Going on to infinity. So, this is the diagram. In this diagram, we have to pick our region. Here we are having two parts. The one is upper one, second one is lower one. So which is our region? Actually, already I said you the region means it is bounded by maximum number of the lines. If you choose the lower part is region means in this part it has the line x equal to y equal to 0. But x equal to 0 is missing and y equal to infinity is missing. Okay, suppose if you are choosing this part means what happen? It is bounded by x is y, x is 0 and y is infinity. So it is bounded by maximum number of the lines. So the upper part only is our region. Okay. So according to our region, what we have to find first means we have to find the y limit first because we are going to change dx dy to dy dx. Y limit first means we have to draw a line parallel to y axis in our region. Okay. So this is our region. Here we draw one line. So this is the starting point of the line. Here what is the value of y? Here the y, it touches the line whose equation is x equal to y. That is y is x. So y varies from x to, and what about the upper limit? Here the upper limit is, here the region is going on to infinity. Okay, so y varies from x to infinity. This is the inner integration limit. Next, we have to find outer integration limit, that is for x. Already I said you for the outer integration limit, the limit should be only constant. In our region, we have to write the minimum and maximum value of our variable x. Here x starts from 0. So the lower limit is 0. And what about the upper limit? See here y equal to infinity, and also it is bounded by x equal to y. So when y is infinity, what happened to the value of x? S is also equal to infinity. So the maximum value of x is infinity. So y varies from 0 to infinity. So our integration I equal to double integration. What is our function? They have given y e power minus y square by x. Y e power minus y square by x. Here we are changing the order dx dy to dy dx. Dy dx. And y limit is x to infinity and x limit is 0 to infinity. Now, this is the way to change the order of the integration. Now, we have to evaluate the integral. We have to find the value of the integral. Okay, here the inner integration is dy with respect to y. So, we have to integrate with respect to y means we have to treat this x as a constant. Okay, how to integrate this function? Here, we have to use the substitution method. Put y square equal to t. So, 2y into dy equal to dt. So, y into dy equal to dt by 2. Okay. And we have to find, we are changing y to other variable t. But here the limit they are given is only for the variable y. Y only varies from x to infinity. So here we have to find the corresponding limit of the introducing variable t. So when y equal to 0, here y equal to x. The lower limit of y is x. Here substitute y equal to x. When y equal to x, t equal to x square. Here we are substituting y equal to x. Next, what is the upper limit? Y equal to infinity. T value is infinity square, that is nothing but infinity one. Okay. So here what we have to do, write outer integration as it is. Inner integration, what we changed, x square to infinity, and we are substituting y square is t. So it is e power minus t by x. Y into dy, what is this? Y into dy is nothing but dt by 2 into dx. Now it is looking very simple function to integrate. Here how to integrate means take the constant outside 1 by 2, 0 to infinity, e power minus t by x. Here we are integrating with respect to t. Okay, with respect to t. So this one x is a constant. Okay, so integration of this function is e power minus t by x upon minus 1 by x. Okay, we have to write, I think you remember the integration of e power ax dx means what is that? E power ax upon a. So in the place of a, what we are having? Minus 1 upon x. Here the limit we have to apply. The limit is x square to infinity dx. So of 0 to infinity minus x, that is the denominator. Here we have to apply the limit for t only. First apply the upper limit. Okay, t equal to infinity. So it is e power minus infinity minus apply the lower limit. T equal to x square means X get cancelled. We will get e power minus x dx. And we know the e power minus infinity value is 0. Okay. So, half into 0 to infinity x e power minus x dx. So, this is our outer integration. So, we finished the inner integration and also we applied the limit. Now, we have to integrate with respect to the variable x. Here, how to integrate means by using integration by parts. What is integration by parts? Integral u dv equal to uv minus integral v dv. Here what is u means? U is x and dv is e power minus x dx. Here u equal to x. According to the formula, what we have to find? We have to find du. So du is dx. According to the formula, what we have to find? dv. Okay, how to find v from dv? By integration. So, v equal to integration of this one is e power minus x. Plus e power minus x into minus 1. So, which is equal to of uv minus x e power minus x minus integral v du. So, e power minus x du dx. Here we are having minus sign. So, it will become plus. Okay, the limit is 0 to infinity. So, of minus x e power minus x. Again, we have to integrate this function. Integration of e power minus x is minus e power minus x. Limit is 0 to infinity. Now, we have to apply the limit of when we apply upper limit e power minus infinity is 0. So, both the term is 0. When we apply the lower limit, here when we substitute x equal to 0, the first term is 0. Here x equal to 0 means e power 0 is 1. So, the answer is 1 by 2. So, the next problem, change the order of integration and evaluate integral 0 to 4 So here they are mentioning order. We have to change the order and evaluate. Why we have to change the order and evaluate? What is the need? Because sometimes the integration may be difficult when we do as it is. While changing the order, it is it is easiest to solve. Okay, that's why we prefer changing the order. Um, Here see this problem. The inner integration limit as the variable x. So definitely it is for the other variable y. If it is y means the outer is for x. The order should be dy dx. So they have given correctly. So here what is our aim is we have to change dy dx to dx dy. That means we have to find out the x limit first. Okay. For that we have to find out our region. So the region of the integration is bounded by the lines. What are the lines means? What is the limit they have given? Y varies from this lower limit to upper limit. So y equal to x square by 4, y equal to 2 root x equal to 0, x equal to 4. So here we have to draw the diagram for this. First one, what is the first one? Y equal to x square by 4. That is x square equal to 4y. X square equal to 4y is nothing but the parabola. Okay. So it is a parabola like this. X square equal to 4y. Another one, y equal to 2 root x. Y equal to 2 root x means that is when we squaring on both sides, we will get y square equal to 4x. So again, it is a parabola. It is symmetrical about the x-axis. The next one is x equal to 0. So x equal to 0 is nothing but y-axis. The next one, what they have given, x equal to 4. Here, the intersection of the two parabola is nothing but 4, 4. So, x equal to 4 is nothing but it is a line parallel to y-axis. So, x equal to 4. Okay. Here, which is our region? We have to pick our region. So, this is the one part and this is the another part. See, if we are choosing this region, means what we are having? X equal to 4 and some parabola curve and x-axis. But we don't want x-axis. Okay, so usually we need the region, it means it should be bounded by maximum number of the lines. So this part only it is bounded by two parabola and starting from origin and end with x equal to 4. Okay, it is covered by all the lines. So this is our region. Okay. After finding the region, we have to find out the x limit first. For finding the x limit, we have to draw a line parallel to x-axis in the region. So it is the starting point of the region. Here, what is the value of x? Here, it touches this parabola, whose equation is y square equal to 4x. That means x equal to y square by 4. So, x varies from y square by 4 to here it touches, this line touches this parabola whose equation is x square equal to 4y. So, x square equal to 4y means x equal to 2 root y. Next, we have to find outer integration limit. Outer integration limit should always be constant. So here in this function, we have to write the minimum and maximum value of y. So here it starts from origin. So y lower limit is 0 and upper limit of y is 4. Okay. So y varies from 0 to 4. So our integration equal to y is 0 to 4 and x is y square by 4 to 2 root y. So here what is the function they have given? The function is no function. Only we have to change dy dx to dx dy. Now we finish the change order. We changed the order. Now we have to do the integration. First integration with respect to the x. Okay, integration of dx is nothing but x. So 0 to 4 x. Here the limit is y square by 4 to 2 root y dy. Now apply the limit 0 to 4. When we apply the upper limit, we will get 2 root y minus lower limit y square by 4 dy. Now we start to do the integration with respect to y. Root y integration. So root y means y power of. So y power of integration y power 3 by 2 by 3 by 2 minus 1 by 4 y square integration y cube by 3. Here the limit is 0 to 4. So the first term is 4 by 3, 4 power 3 by 2 minus 1 by 12, 4 cube. When we apply the lower limit, we will get 0 only for both the terms. So when we simplify these, we will get the answer is 16 upon 3. The next problem, evaluate 0 to 3. So again, it is the problem representing the changing the order of integration. Here the inner integration with respect to x they have given. See the limit. The limit, inner integration limit as a variable y. So definitely it is for x. So the outer integration limit, it is for y. So the order should be dx dy. So they have given correctly. Now what is our aim is we have to change dx dy to dy dx. That means we have to find out the y limit first in terms of variable. Next we have to find x limit in terms of constant. So first we have to write our region. So the region of the integration is bounded by the lines. What is the lower limit? X equal to 1 and upper limit x equal to root of 4 minus y. And here they have given y varies from 0 to 3. So y equal to 0, y equal to 3. Okay. So here first we have to draw the diagram for this. This is definitely it is a curve. Okay. Here we have to need the point. Okay. So x equal to root of 4 minus y means x square equal to 4 minus y. Okay, now we can give some value for x and y to find the point. Then only we can trace the curve. Okay, when we put x equal to 0, what will happen? Y equal to 4. Okay, y equal to 0 means x equal to plus or minus 2. Okay, here we can put x equal to 1 because x equal to 1 they have given in the question. Then only we can find the intersection region. So substitute x equal to 1 means y equal to 3. Automatically we can get 3. X equal to minus 1 means also we will get y equal to 3. Here, what are the points? 0, 4. Okay. Here, plus or minus 2, 0, 0, minus 2, 0, and 1, 3. Here we can draw 1, 3. So the curve is like this. So this is our curve. This is the curve for the equation. What equation? X square equal to 4 minus y. Okay. Next we have to write x equal to 1. Okay. X equal to 1 means here it is 1. This is only 1. Okay, x equal to 1 means it is nothing but line parallel to y-axis. So this is x equal to 1. What is that? Y equal to 0. Y equal to 0 means x-axis. Y equal to 3. Here we are having 3. Here 3. Because 1 comma 3 means here it is 3. So y equal to 3 means it is a line parallel to the axis. Okay. So which part is our region? Here we are having two parts. 1, 2, 3. See here, this part is bounded by the upper part bounded by the curve and y equal to 3. So this part, it is like a one rectangle or square. Okay. And this part is here, it is bounded by curve, y equal to 0. Okay, here x equal to 1, y equal to 3, because this point, the maximum point of this region is 1 comma 3. 1 comma 3 means x equal to 1, y equal to 3. So this part only bounded by maximum number of lines. So this is our region. Okay. Here actually what we need, y limit first. So y limit first means here you have to draw a line parallel to y-axis. In this our region. So here this is the starting point of the line in the region. What is value of y here? Y equal to 0. So here y equal to 0. Here what is the value of y? It touches the curve. Okay, this is nothing but the curve whose equation is x square equal to 4e minus y. So that means y equal to 4 minus x square. So y varies from 0 to 4 minus x square. Next, we have to find x limit. So x limit means in this region, the outer integration limit. X limit means outer integration limit. It should be always constant. In this region, we have to write the minimum and maximum value of x. See here is starting from here to here. Okay. Here, what is the value of x? Here they have given 1 comma 3 means here the value is 1 comma 0. Okay. So x varies from 1 to 2. 1 to so our integration is I equal to y varies from 0 to 4 minus x square and x varies from 1 to 2. And here what is the function they have given? X plus y dy dx. Now we change the integration. We change the order of the integration. Now we have to evaluate it. Okay, first integration with respect to y, inner integration. So we have to treat this x variable as a constant. So write outer integration as it is. So the first term x, the integration is xy. Second term y, the integration is y square by 2. 0 to 4 minus x square dx. Now we have to apply the limit for y. So 1 to 2 x, y value 4 minus x square plus 4 minus x square whole square by 2. Now we finish the inner integration. Now we have to do outer integration with respect to x. Okay, so it is like a very simple one. So the first term is 4x. So the integration is 4x squared by 2. The second term x cube. So that is x power 4 by 4. Here I am taking off outside. A minus b whole square formula. So a square that is 16. Integration 16x. B square is x power 4. Integration x power 5 by 5. Minus 2ab, 8 x square. X square integration x cube by 3. So the limit is 1 to 2. So it is a very big calculation. First find the upper limit minus lower limit. So the answer is 241 by 6. Next problem, evaluate 0 to 1, integral 0 to 1 minus x square, e power y by e power y plus 1 by changing the order of integration. See here the inner integration limit as a variable x. Here the inner integration limit as a variable x. So definitely it is for y. Because x varies from 0 to root of 1 minus x square means there is no meaning. Okay. So y only varies from 0 to function of x. And it is y means the another one is for the variable x. So here first we have to rewrite the given question because what they have given here the order they have given is dx dy which is not correct. So we should write dy dx. Okay. So our question is 0 to 1, 0 to root of 1 minus x square e power y by this dy dx. Okay. Here, don't think we changed the order. Here, we are not changing the order. We are rewrite the given question. Okay, now only we have to think, okay, here they have given, now it is changed to the correct order. We have to change the order dy dx to dx dy. That means we have to find the x limit first. X in terms of the variable y. Here what they have given the lower inner integration limit y in terms of the variable x. So to change the order, we need the region. So now we have to write the region of integration is bounded by the lines here. What are the lines? Y equal to 0, y equal to root of 1 minus x square. And x equal to 0, x equal to 1. So y equal to root of 1 minus x square means when we squaring, we will get y square equal to 1 minus x square. That means x square plus y square equal to 1, which is nothing but a circle with the center origin and radius 1. So this is nothing but our given circle. X square plus y square equal to 1. What is the another line? Y equal to 0. Y equal to 0 means x-axis. Next, x equal to 0 means y-axis. X equal to 1. X equal to 1 means here the radius is 1. So here it is 0 means here it is 1. 1, comma 0. So x equal to 1 means it is a line like this. Straight line parallel to y-axis. So which is our region? Here we are having 4 parts. So x is 0, y equal to 0 means definitely the region is definitely lies in the first quadrant. So this is our region. Here what we have to change? We have to change dy dx to dx dy. We need x limit first. So draw a line parallel to x-axis. Here what is the value of x? Here the starting point of the line is touches x equal to 0. So x equal to 0. Here the end point touches the circle whose equation is x square plus y square equal to 1. So x equal to root of 1 minus y square. So x varies from 0 to root of 1 minus y square. And y limit is here the lower minimum and maximum value of y. Here y equal to 0 and the maximum value of y is 1. So y varies from 0 to 1. So our integration is y is 0 to 1 and x is 0 to root of 1 minus y square. And what is our function? This is the function e power y by into root of into dx dy. So first integration with respect to x. So integration with respect to x means y is constant. Here we have to use this formula dx by root of a square minus x square is sine inverse of x by a. This formula we have to apply. So integration 0 to 1. Here y is constant. So write e power y upon e power y plus 1 as it is. Sine inverse of x by what is a means this two term. These two term together is our a because 1 is constant, y is also a constant. Sine inverse of x by a. X by a is nothing but 1 minus y square. Okay, in this problem, a square is nothing but 1 minus y square. Now, when we apply the limit, when we apply the upper limit, what you will get? Sine inverse of 1, which is nothing but pi by 2. Sine inverse of 1. Minus lower limit, sine inverse of 0, that is 0. Sine inverse of 1 is pi by 2. So take outside 0 to 1 e power y upon e power y plus 1 dy. So what is the integration of this one? So it is of the form dx by x. So it is nothing but log. Log of, we know integration of dx by x is log x. So differentiation of this one is nothing but e power y. So it is because e power y differentiation e power y. One differentiation 0. Okay, so it is of this format. So it is nothing but log x. Instead of x, what we are having? E power y plus 1. The limit is 0 to 1. So pi by 2, apply the upper limit. Y equal to 1 means log of e plus 1. Minus, apply the lower limit. E power 0 is 1. 1. So we will get log. So So pi by 2 log of v plus 1 upon. So this is the answer.